Okay, continuing where we left off. Let's try number 78. Square root 150, m to the 9th, n to the 3rd square root. So there's technically a little 2 there. Let's break apart the 150. That's 15 and 10. 15 is 3 and 5. 10 is 2 and 5. It's a square root, so I just need to circle two things to so they escape the radical. So those 5's escape. So let me draw the little square root sign. So those two team up, right? Because of square root, we have to circle two things and they escape. That means the 3 and 2 did not escape. So multiply them, that's a 6. And then now the letter stuff. The letter stuff's easy, right? M to the 9th, we're taking out chunks of 2. So that's going to be 4 of them and 1 left over. You can put a 1 or not. And then see, how many chunks of 2 can you take out of n to the 3? 1 of them. You can put a 1 there if you want. How many left over? 1. Ta-da! Question B. That's the correct answer. Circle it. 78B. Cube root of, what am I doing? 78B. Cube root 81. P to the 7th. Q to the 8th. Okay, break apart 81. 9, 9, 3, 3, 3, 3. Because it is a cube root, I need to circle 3 of them for them to escape. So let's see, put the little cube root sign here. Cube root. Those ones escape, so that forms a 3, right? This guy did not escape, so he's stuck underneath the radical. And now the letter stuff, easy. P to the 7th, take out chunks of 3, 2 of them. 1 left over. Chunks of 3 from Q, 2 of them. And so 6, 2 left over. Ta-da! 78C, ooh, 4th root. So C, 78C, 4th root, 162, C to the 11th, D to the 12th. So the 162, that's going to be 2 and 81, 9, 9, 3, 3, 3, 3. We need to circle 4 things. 1, 2, 3, 4. So that means a 3 escapes. So put the 4th root. A 3 escapes. A 2 does not escape. And now the letter stuff. Chunks of 4. The letter stuff, hopefully you agree, is easy. C to the 11th. How many chunks of 4? 2. So that's 8. 2 times 4 is 8. 3 left over. And D to the 12th. How many chunks of 4? 3. Boom. And then that little 4, maybe make it a little bit tinier. 4th root. Ta-da! And there's our answer. Okay, that was 78. What do they want? Just clean things up? Simplify. I guess we'll jump down to 84. Let's do a -1. Okay. 80. Fifth root of -486. Oh my gosh. Well, you could take 5th root odd of negative, so I guess we have to break it apart. So if I pull out a 2 using my calculator, 2, 4, 3, and then 2, 4, 3, I think 3 goes into 2, 4, 3. Calculator. Oh, goes 81. 3 and 81. Okay. 81 is a 9 and a 9. That's a 3, a 3, a 3, a 3. We need to pull out 5 of them. 1, 2, 3, 4, 5. So this is going to be a 5th root. The 3 escapes. And what's left inside? A 2. And then that negative, we're just going to bring that outside. because you could have thought of this as a negative 3, negative 3, negative 3, negative 3, negative 3, negative 3. So if I circle 5 negative 3's, you see how it brings out in front. So basically it's a fifth root of a negative root, so I knew that the answer was going to be negative. So that was a little weird. Hopefully you caught that I knew the answer had to be negative, or instead of 3's, I technically factored out negative 3's because there was a negative up there. That was tricky. And then, so then part B is easy. The sixth root of negative 64. Even. 6 is even. You can't take even roots of negatives. No real answer. Is that what we said? No real answer? Can't remember what the book told us to say. No real, not real number. Not real number. That's what the book told us to say. Okay. 86. 86. 3 plus root 125. So the 125 is 5 times 25. 5, 5. It's a square root, so circle 2 of them. So that's going to be, those escape, and then that one does not. And then there's a 3 plus hanging out in front. So the little 3 plus is just going along for the ride. Okay, 3 plus that mess. Clean up that mess. Okay, 3 plus that mess. Okay. And then 86 part B, 15 plus root 75 all over 3. Let's clean up root 75. So rather than break it all apart, I recognize that 25 is in there. So isn't radical 75 just radical 25 times radical 3, right? 3/4 and 75 cents. And square root of 25 is just 5. So root 75 I can replace with 5 root 3. So this is just 15 plus 5 root 3, right? Just replaced all over 3. And yeah, I think 5, 3 plus root 3. I was seeing if it reduced. I could pull out a 5 from each, but the 5's not going to reduce with a 3. So it seems pretty good. So if I were to pull out a 5, it would be 5, 3 plus root 3, all over 3. So this is prettier than that, but nothing reduces. So I'm not sure if the back of the book would have this one or this one. Okay. And then they just play the game with fractions. Oh my lordy. Oh my lordy. Okay. The never-ending chapter. The never-ending chapter. Quotient property. Let's see. So there's a bunch of ways to do, let's see, 88. We have the square root of 72 over, it's a big square root like that. So there's a couple ways you could do this. You could say this is the square root of 72 over the square root of 98. That works. So you could go ahead and just keep going like that. That's one way to do it. Or you could reduce this fraction. So you could also say, well, 2 goes into both. So isn't that 36 over 49? Right? Which would give us the square root of 6 over the square root of 7. I'm sorry. Which is the square root of 36 over the square root of 49, which gives us 6 over 7. So had I kept going this way, this would give me, this is the square root of 2 times the square root of 36. This is the square root of 2 times the square root of 49, which gives us, see the root 2's cancel each other. Square root of 36 over 49 is what we had over here. 6 over 7. So all roads lead to Rome. So the question is, do you break it apart early, or do you reduce and then break it apart? So usually you reduce and then break it apart. Okay, that was part A. Let's try part B. Cube root of, big cube root of 24 over 81. So it's a big cube root, so let's just, it doesn't reduce, or does it by 3? What goes into both? 3 probably goes into both. 3 goes into both? 3 goes into there 8 times, 3 goes into there, like that. So that's the cube root of 8 over the cube root of 27. Cube root of 8 is 2, cube root of 27 is 3. Aha. Okay. 88 part C. 88C. Fourth root, good gosh, of 6 over 96. Does 6 go into 96? 6 into 96. 96 divided by 6. 16 times. Okay. So 6 goes in here once. 6 goes in here 16 times. So this is just the fourth root of 1 over 16, which is the fourth root of 1 over the fourth root of 16. Fourth root of 1 is 1. Fourth root of 16 is 2. 2 times 2 times 2 times 2 is 16. Okay, so that's with the letter stuff. And then we'll do some with the, that's with the number stuff. Oh my gosh. And then we'll do with the variable stuff, and then we'll do both at the same time. Okay, so let's try 92. Let's get a new pen. Should we pause to get a new pen? No way. We keep filming. Okay, 92. We have square root p to the 20th over p to the 10. So isn't that just the square root of 20 over 10? So that's 20 upstairs, 10 downstairs. That's just 10 upstairs. Square root of p to the 10th is p to the 5th. Okay. Question B, the 5th root of d12 over d7. 12 over 7, 12 minus 7 is 5. So it's just the 5th root of d to the 5th. 5th root of d to the 5th is just d. And C, 8th root, m12, m4. 12 minus 4 is 8. So this is the 8th root of m to the 8th. 8th root of m to the 8th is just m. Whew. Okay. 96. Square root 108 y to the 4th all over 49. Okay, 108 over 49 does not reduce, so let's just call this the square root of 108 y to the 4th. Oh, I can do that, and the bottom is square root of 49. Oh, I can do that. Oh, so they're just throwing a bunch of problems and mashing them into one. Okay. Sometimes you can reduce, sometimes you can't. Square root of 49, that's 7. I like getting something right. 108. 108, that's 2 times 54, which is 2 times 27, which is 3 times 9, which is 3 times 3. It's a square root. So those 2's match up, and those 3's match up. So there's a square root symbol. That releases a 2. That releases a 3. 2 times 3 is 6, so 6 escapes. This 3 does not escape. And then the letter stuff, the square root of y to the 4th. Put a little 2 there. How many chunks of 2 can you pull out of y to the 4th? 2 of them. Ta-da! Okay. Let's see, do they get more difficult? Let's go to 104. Let's see. If I save paper right here, will it work? 104. 72 x to the 5th all over y to the 6th. Make sure your square roots are drawn bigger like that. Okay. So I guess I'm just going to have to call that the square root of 72 x to the 5th over the square root of y to the 6th. The bottom should be easy. The square root of y to the 6th, that's just y to the 3rd. 72. 72 2 times 36. Oh, 36 is a perfect square. So you could think of, you could keep breaking it apart. I'll keep breaking it apart. 6, 6, 2, 3, 2, 3. So see, there's a 2, there's a 2, there's a 3, there's a 3. That 2 does not have anyone. So those form a 2, those form a 3. 2 times 3 is 6. So that means the 2 did not escape. And then you have x to the 5th. Put a little 2 there, square root. How many chunks of 2? 2. How many left over? 1. Redo that one. Make sure it makes sense. I went a little fast there. I was trying to show you that with 72, if you recognize square root of 72 as square root of 36 times square root of 2, it's just 6 root 2. 6 root 2. So recognizing square roots is the faster path. Breaking it apart using the factor method, it always works. It's just slower. What was that, 104A? Okay. 104B. 104B. 5th root, 9, 6, r to the 11th, s to the 5th. 5th root, 96, r to the 11th, all over 5th root, s to the 5th. 5th root of s to the 5th is easy, that's just s. Okay. Now this one, 96, let's break it apart. What do we say, 4 and 24. 4, 6, oh, that's 2, 2, 2, 2, 2, 3. It's a 5th root, so 1, 2, 3, 4, 5 of them. So that means we have this 5th root. Why do they use s's? 5th root, and then the 2 escapes. The 3 does not. Okay, and then the letter stuff, it's r to the 11th. So how many chunks of 5 can we take out? 2. How many left over? 1. You can put a little 1 there if you want. Does anything reduce? No. We're done. That's a 5th root there. It's a 5, and that's an s. Oy vey. 104C. 6th root. I'm just going to break it apart right away. Save a space. Save a second. U to the 7th over 6th root. V to the 12th. One's a U, one's a V. Okay. The bottom's easy. Take out, how many groups of 6 can we take out? 2. Done. So the bottom, easy peasy. 128, 6th. So off to the side. 128. It's 2 and 64. 2 and 32. 2 and 16. 4, 4, 2, 2, 2. 2. We need 6 of them. 1, 2, 3, 4, 5, 6 of them. That one did not escape. So the circled ones, that means the 2 escapes. And that little 2 did not. And then the letter stuff, how many groups of 6? There's 7, so we can take out 1 group. How much is left over? 1. Anything reduced? Nope, we're done. Okay. That's basically about it. And then I think what we'll see is, as we move on, then they'll have situations where things can reduce. That's it. So let's just try one of those, and then I will be done. We'll just do 114A. That should be plenty. So square root of 72. N to the 11th, all over the square root of 2n. The bottom doesn't really clean up. The top, 72, square root of 72 is 8, 9, 4, 2, 3, 3, 2, 2. It's a square root, so those 2's combine, those 3's combine, and this guy does not escape. So upstairs, the 2 and the 3 multiply gives us a 6. This 2 does not escape. And then it's a square root. Put a little 2 there for a second. How many chunks of 2 can we take out from n to the 11th? 5. And what does it leave us with? One of them. And then downstairs was a square root of 2n. And then as I was saying before, things can cancel out. Yay! Dust settles. 6n to the 5th. Okay. So you should totally be able to handle 8.2.